Hi, my name is Alejandra Garcia. In this video, I will present basic concepts of big data and how to use existing tools to perform data science tasks. The prediction of natural phenomena can be achieved with good small datasets and elegant mathematical formulas. However, if we want to model more complex entities like human beings, like the language or behavior, there is a tendency of having very complex algorithms. But in fact, just by increasing your training dataset, you will be able to create a good performing model that is based on simple algorithms. This finding was described in The Unreasonable Effectiveness of Data by Google researchers. Nowadays, it's very easy to have datasets that cannot be stored in a single computer. Retailers, for instance, are now interested in learning more about customers, so they use the social networks to try to extract information that people share about their services or products. But how all this data can be stored and processed? The big data revolution is now democratized thanks to the creation of Hadoop and its ecosystem. This allows basically to distribute files in clusters of computers and to parallelize computation to process this big amount of data. This Apache project was inspired from two Google research papers, one the Google File System paper and the Mapreduce. To explain Hadoop, I will use the book metaphor. Imagine that we put all Wikipedia information in a book. This will be a very big book, hard to carry and hard to read. The same happens when we try to store a big file in a computer. Sometimes we are not able to open it and to work with it. So what we could do? So we can take this big book and split it into several small books. In Hadoop, we split a big file into blocks of data. Then we can have much more books that we could put in a bookshelf. In a bookshelf, we can still manage dozens of books. Like in a computer, you can have a limited amount of files. But when it comes to store hundreds of books, we better have a library with dozens of shelves and a classification system. In Hadoop, you can have more computers to store more blocks of data, and a dedicated computer to store and manage the metadata about the data blocks. So the Hadoop cluster will have one name node and several data nodes. These data nodes will store blocks of data. These blocks of data are the result of splitted big files. So each of these data blocks have a size and have also a replication factor. This information is stored in the name node. The name node is the one that is going to know where data blocks are stored in each data nodes. So Hadoop is fault tolerant because it prevents data loss by replicating the data. So if you have one node that crashes, you are sure that a data block found in this node that crashes is also available in the other data nodes. These data nodes are in charge of serving all the data from the clients. So all data nodes will be sending heartbeats to the name node, so the name node knows who is alive. They are also sending block reports with information of what blocks are in each data node. So this is how data is stored and managed in Hadoop, but what is about the processing now? Continuing with the books metaphor, let's say that we have thousands of books in dozens of bookshelves, and we want to categorize all these books. So if we had one person doing the categorization, it could take several days of work. But in the Mapreduce approach, the goal is to split computations. So we're going to have several persons doing this categorization. So each of the persons we have will take a set of bookshelves and will categorize the books. So this part is called the mapping part. So each person have a number of books from each category. After they are going to group all the categories they found for the books and sum up the results, so we know how many books we have from each category. So the Hadoop architecture allows to process big data, but we have to implement algorithms that follow the Mapreduce concepts. This means that we have to think on how to decompose an algorithm into Mapreduce tasks. However, in the Hadoop ecosystem, there are tools that are Mapreduce enabled. Here you can see some of the Hadoop ecosystem tools. So the laying components of these ecosystems are the Hadoop distributed file system and the distributed processing framework. All these tools complement the ecosystem. HBase, for instance, is used most for a transaction-oriented storage and also works with Hadoop. Hive and Pig allow to query the data on the HDFS and to use Mapreduce to perform these query operations. For this presentation, I would like to introduce you Pig. So Apache Pig is a platform for analyzing large datasets. It provides a high-level programming language to perform SQL-like queries, but it uses a Mapreduce operation, so it can perform the queries in the Hadoop file system. Pig is very flexible concerning schemas, and it's one of its strengths. It can be used for structured and unstructured data. Here I present some of the data types that Pig can handle and the data model. The data model is based on field, which is one data element, for instance Bob, a map, which is a name associated to a data element, for instance name Bob, age 55, a tuple, which is an ordered set of fields, for instance Bob 55, a bag, which is a collection of tuples, for instance Bob, Sally, John with their ages. And finally we have the statements used for making the queries, for instance select statements, join statements or load statements, etc. So let's go to the exercise. The objective of this exercise is to analyze some datasets using Pig. I will show how to load data and work with data, how to perform some queries, and how to save some results. This exercise uses a dataset from the Driven Data website. This is an organization that publishes data science challenges. The competition I choose is called Keeping It Fresh. This competition is about restaurants inspections for food safety and public health. The goal is to use data from social media to narrow the search for health code violations in Boston. For this exercise, you need to have installed Hadoop and Apache Pig. To access this exercise, please follow this link to my Wikipedia page. Thank you for watching this video. If you have any question, don't hesitate to leave me a message. Thank you very much.